diameter of a circle is given, find the radius. So this section should have been fairly simple, hopefully, since the radius is half the diameter. So half of 8 is going to give us 4 feet for the radius. And then number 2, diameter of 9 centimeters. So the radius is going to be half of 9, or 4.5 centimeters. And 3, a diameter of 2.1 meters. So 1/2 of 2.1 going to give us 1.05 meters. Make sure on the test that you include the units, or you'll lose points there. And then number 4 through 6, they're giving us the radius and wanting us to find the diameter. So we're just applying the reverse of the principle we just used. The diameter is twice the radius. So our diameter is going to be 2 times 21, which is going to be 42 centimeters. Next one is going to be 2 times 33, or 66 feet. And the last one there, that was going to be 2 times 2.9, or 5.8 meters.
I was just wondering.
Alright, so using the diagram below, match the notation with the term that best describes it. So number 7, we're looking for a chord. Right, this section is really just to see how well you can apply the vocabulary. Right, so a chord is a segment whose endpoints are on the circle. And we've only got one segment whose endpoints are on the circle that is not a diameter, and that is segment DE, which is G. Right. And make sure you pay attention, because a chord is a segment. So it's DE is part of this line, but we just want the segment portion for the chord. So we're getting DE with the little line segment above it, not DE with the line above it up there. All right, 8, point of tangency. Will be a point where a tangent line intersects the circle, which we actually have 4 of those here. One at A, one at B, one at G, and one at H. So A, B, G, or H. The only one of those on our list is A, which is letter D. 9 and 10 are common tangents. 9 is a common internal tangent. 10 is a common external tangent. Remember, the difference is all based on an imaginary line that goes between the 2 centers of the circles. So a line that goes between C and F. If it's a common internal tangent, then it's tangent to 2 circles and crosses that line. If it's a common external tangent, then it is tangent to the 2 circles but does not cross that line. So common internal tangent is going to be right here, line BH, that crosses the blue line and is tangent to both circles. So, or BG, I mean. So that is B. And then the common external is going to be AH, that is tangent to both circles but does not cross this blue line here. So line AH, or F is the choice. 11 is for a center. So we've got 2 centers, either point C or point F, and the one on the list is C, which is choice H. Then a radius is going to be a segment that goes from the center to a point on the circle, which we have multiples of those. You could do FH, FG, CA, CE, or CB. And the only one of those on the list is segment CB, or A. Diameter is going to be a chord that goes through the center of the circle. And so only have one of those, that's EB, that goes through point C and has endpoints on the circle. So that's EB. And then a secant is going to be a line that intersects the circle in two places. So you've got this line here going through the circle, hitting it at E and D. So that is line DE, as opposed to where we use segment DE for the chord earlier. This is line DE, which is C. So make sure you pay attention to those symbols above the letters. All right, 15 through 20, we're using the information they gave us to come up with all the other arcs and angles that they asked for. So starting off, when we look at the picture, we got angle AEM that's 55 degrees and angle CEN that's 65 degrees. Those are both central angles. And one thing we've learned is that the arc attached to a central angle is the same measure as the central angle. So that means that arc AM out here would be 55 degrees since the central angle there is 55. And arc CN would be 65 because angle CEN, that central angle, is 65 degrees. And then to find the measure of arc AC, we have to recognize that segment MN is a diameter, which cuts the circle in half, so that these three arcs up here are going to add up to 180 degrees, since they're half of the circle. And so measure of arc AC, we can take 180 and subtract those two angles that we, or two arcs that we know, 55 plus 65, which would be 180 minus 120, or 60 degrees. So then 16, looking for arc NB, which is down here. Now there are two different ways we could look at this one. We could do it just like we did the last one. We can see that AB is a diameter. And so AC, arc AC, arc CN, and arc NB all added together have to equal 180. So we do 180 minus 60 plus 65. Or, even easier than that, since AB and MN intersect, then angle AEM and angle NEB are both vertical angles. And we know that they would be the same since they're vertical angles. So we automatically know that that angle is going to be 55. And if that central angle is 55, then we know arc NB is also 55 degrees. And 17 is asking about angle BEN, which we just came up with 55 degrees for that, so that one's already figured out. 18, the measure of arc ACN. So going from A to N. So basically arc AC plus arc CN, or 60 plus 65. Okay, 125 degrees. Measure of arc MAC is going to be arc MA plus arc AC. So that's 55 plus 60. 115 degrees. And then 20, the measure of arc MCB, which is all four of these arcs added together. So 55 plus 60 plus 65 plus 55, which would be 235 degrees. Or you could have looked at it as knowing that these three were 180 and then adding 55 to the 180. Either way. All right, so next section, 21 through 24. Find the unknown measure of angle ABC or arc AC. So in this situation, we have an angle whose vertex is on the circle, which makes that an inscribed angle. And the rule when we're dealing with inscribed angles is that the angle is half the measure of the arc it intercepts. So the measure of angle ABC should be equal to half the measure of arc AC. Or if you look at that in reverse, the arc is twice the size of the angle. So applying that rule here, angle ABC, you see the little box there, that means that's a right angle or 90 degrees. So the measure of arc AC should be equal to 2 times 90 degrees. Measure of arc AC is going to be 180 degrees. 22, they give us the arc, and we need to find the angle. So the measure of angle ABC is half the measure of the arc, or half of 84. That'll be 42 degrees. 23, you got angle ABC given to us as 65 degrees, and so the arc we know should be twice the measure of the angle. So the measure of arc AC will be 2 times 65. So the measure of arc AC equals 130 degrees. And then 24, we've got arc AC given to us as 200 degrees. The measure of angle ABC is going to be half of that, so half of 200. Be 100 degrees. All right, so 25 through 27, a little different situation. We've got a chord intersecting a tangent line at the point of tangency. And when we have that happen, the angles formed are half the measure of their intercepted arcs. So kind of the same rule we just went through. The angle is half the arc, or the arc is twice the angle. So for 25, the measure of angle 1 should be half of the arc that it intercepts, which is 260 degrees. So measure angle 1 is going to be 130 degrees. All right. 26, we want the measure of arc MLK, which is the arc intercepted by angle K. There at 135 degrees. And so the measure of arc MLK is going to be twice the measure of the angle, 2 times 135 degrees. So the measure of MLK, 270 degrees. And then 27, the measure of arc AB. So they gave us the angle, we're finding the arc. The measure of arc AB should be 2 times the angle, 80, 160 degrees. Alright, so this next section has a couple of different rules we have to follow. The first one, we've got two chords intersecting inside the circle. So the rule is that the measure of an angle there is equal to half the sum of its arc and the arc of its vertical angle. So those two arcs highlighted in blue would be, angle 1 is half the sum of those two arcs. Problem is they didn't give us the measure of those two arcs. They gave us the measures of the other two arcs. But since all four arcs together are going to equal the whole circle, and we just need to know half of the sum of these two, if I subtract these two angles from 360, what's left would be the sum of the two blue arcs. So to solve this one, we're going to say that the measure of angle 1 is equal to 1/2 of 360 minus 125 plus 105. Which that's going to give us the sum of those two arcs that go with the angle and its vertical angle. The measure of angle 1 equals 1/2 of 360 minus 230. Half of 130, or measure of angle 1 is going to be 65 degrees. All right, 29, we have two secants intersecting outside the circle, and the angle that those two secants form is going to be 1/2 of the difference between the two arcs that it intercepts. So the arcs that it's intercepting is the 122 and 64. So the measure of angle 1 is going to equal half of the difference of those two, or half of 122 minus 64. Which 122 minus 64 is going to give us 58. Measure of angle 1 is going to be 29 degrees. And 30 looks a little bit different than 29, but it's still the same rule. The angle is equal to half the difference of the arcs intercepted. So we have a tangent and a secant in this case instead of two secants, but it's still, measure of angle 1 is going to equal 1/2 of the difference of the two arcs that are intercepted. So 135 minus 55. Measure of angle 1 equals half of 80. So angle 1 is going to be 30 or 40 degrees. All right, so then 31 and 32, we've got a tangent segment and a secant segment who have a shared endpoint outside the circle. So the rule is that the external secant segment times the entire secant segment is going to equal the tangent squared. So the entire secant segment here is going to be x plus 8. So it's the exterior secant segment, which is the 8 portion, the part that's outside the circle, times the entire secant segment, x plus 8, has to equal the tangent segment squared. So we have x times x plus 8 equals 9 squared. So distribute the 8. 8x plus 64 is going to equal 81. Subtract 64 from both sides. 8x equals 17. And then divide by 8. So our x You could have left it as 17/8, or if you divided it out, that should be 2.125. Then number 30 is the exact same situation. We've got a tangent with a secant, and so figure out the entire length of the secant segment, which is going to be 3x plus 5. And so the exterior secant segment, which is the 5, times the entire secant segment, 3x plus 5, has to equal the tangent segment squared, so 10 squared. Distribute the 5, we get 15x plus 25 equals 100. Subtract 25 from both sides. So 15x equals 75. Divide by the 15, and we get x equals 5. So then, next up, 33 and 34. We're finding, they're given the center, or give the center and radius of the circle based on the equation they give us. And we're using the standard equation of a circle, which is based on x minus h squared plus y minus k squared is going to equal the radius squared. And remember, our center point is the point h, k. So once we pull the h and the k out of the equation, we can build our center. So for 33, the h is what we're subtracting from the x, and since that's plus 3, we had to be subtracting a negative 3. And k, we're subtracting a positive 4, subtracting 4 from that. So remember, when you pull h and k out, they're always the opposite sign of what they are in the equation. So our center here is the point negative 3, 4. And then to find the radius, we have to look at that the r squared is equal to 36. Take the square root of both sides there. And we're going to get 6 for our radius. (34), same idea. Our h is what's being subtracted from the x, and that's a positive 1, so it's going to be a negative 1. And k is equal to what's subtracted from the y, which is 6. So our center point is negative 1, 6. And our radius squared is 2.25. Take the square root of both sides, and our radius is 1.5. And then the last question here, probably one that you looked at and didn't know what it meant to begin with, because we didn't cover that section, because I didn't want to waste a whole day to cover what I can tell you in just a couple minutes here in this one example. So when it says describe the locus of points, that's basically describing what we create when we apply the rule that they give us about the points. All right, so it says describe the locus of points in a plane 3 inches from a given point C. So that's saying if I have a given point C, and I look at all the points that match that locus of being 3 inches from a given point. So if I go 3 inches from that point in all directions, then what do I create? I create a circle. And we're going to be as specific as we can about that circle based on the information they gave us. It's a circle with a radius of 3 inches. And we could even say, and a center of C. Right. That's all there is to that review there.